Henrietta Moon is an entrepreneur of some standing, has founded at least 2 companies of some repute before carboculture. Henrietta is a graduate of the Stanford StartX Accelerator. She has the gift of at least bilocation, perhaps trilocation, because carboculture is in Finland, but it's also in San Francisco, as I understand, with a pilot project. And you're known from time to time to be in London as well. So Henrietta, where are you this morning?
I'm calling in from London actually this morning. So hello everybody.
Well, look, it's great to see you. I mean, you're again at the very cutting edge. You're removing carbon from the air. You're sequestering it for at least 1,000 years. In this country, Henrietta, sometimes we have arguments which last 1,000 years. But nevertheless, it's a long time, so it is a breakthrough technology. So the floor is yours, Henrietta. Thank you for joining us, and thank you to Carboculture. So over to Henrietta Moon, founder and CEO of Carboculture.
Thank you, Martin. Excellent to be here today, and thanks for listening in wherever you are. I know you've heard a lot about carbon removal today, and it's very exciting what's happening in this space. And I hope you'll stay with me while I'll tell you how we're doing it and what our approach is. And so we founded Carboculture because we were thinking that about the most elegant solution to actually physically remove the carbon from the atmosphere. And for that, there are some examples that we've seen today, but we actually wanted to leverage nature, which is already doing it everywhere, every day at hundreds of gigatons scale annually. But let's dive in. So firstly, let's talk about carbon removal and storage, which we've already heard a couple of speakers from today, but I'd like to iterate a couple of things. So here's the timeline. This is from McKinsey. There are similar timelines that you can find from the IPCC or other. And so the black line in the middle is our current trend, where we're going towards, without rapid decarbonization, more than we're actually doing right now. But the 1.5 degree pathway is the safe zone that we need to meet to actually keep global warming in a status that we know we can still safely operate on this planet. And now if you look at that graph, we need to actually halve our emissions by 2030 and then be at net zero, which was mentioned earlier, by 2050. And net zero means we need to actually be emitting zero, or whatever we're emitting, we actually need to be removing. And now I work in carbon removal. My company does scalable and rapid carbon removal from the atmosphere and storage. But I still want to emphasize that carbon removal is not a substitute for rapid decarbonization. All the carbon removal in the world can maybe do 1/3 of the Paris Agreement targets, but 2/3 definitely need to be carbon reduction. So essentially decarbonizing every sector of our society as fast as possible. And for that, we'll look at the carbon removal part, but I'm sure there's going to be a lot of exciting topics around the carbon reductions as well. So here's the thing. Before, we didn't have any strategy for how are we going to do this. And before 2020, we were thinking about carbon offsetting. So if you emit 1 ton, you buy 1 carbon offset. You're actually buying avoidance of further emissions. So let's say you're buying green energy offsets or protecting a forest or something, which are all very needed. But the net emissions into the atmosphere are still 1 ton, even if you've avoided that other ton. Now that's better than 2 tons. But where we're heading now towards 2030 and onwards is that if we're actually emitting something into the atmosphere, we need to physically bring it down. And now this is something that when you see brands or countries make strategies on how to actually get to net zero, you can actually ask the people that, hey, how are you thinking about your carbon removal strategy, and what part of your portfolio today is carbon offsets versus carbon removals? Because today, the voluntary market where we sell our carbon removal credits is 97% carbon offsetting and only 3% removals. So from about today's 3 million tons if I go back to the previous slide, today the removal capacity is 3 million tons. And by 2050, we may need to get to tens of billions of tons. That is us and Climeworks and everybody else combined who was here today, and everybody else in the world who's working on this. So it's quite a steep ramp up. So how do we actually do this? So as said, all the crops and trees and biomass already draw down carbon in hundreds of billions of tons annually. But if you think of leaves in the autumn, when they fall on the ground, they rapidly decompose and return to the atmosphere as greenhouse gases. So we take that biomass before it decomposes, we put it into a patented reactor, and then we take it to a very high temperature for a split second. And in that way, we carbonize it, or we change the form of the biomass. And then the resulting products are three things that we sell. One is the renewable heat. So our process is, I'll get to it soon, but it's an exothermic process, meaning it actually generates more heat. We don't actually need external heat. So we are generating heat that is a valuable source of regenerative heat or renewable heat that can be plugged into a district heating system or into industrial processes or food production units or any industrial scale heat meter. And of course, a lot of the technologies that are other forms of decarbonization or alternative protein manufacturing or other things that are related to climate change mitigation actually need a lot of heat. So we could actually partner with these companies. The second product is biocarbon, so physical biochar or biocarbons. It's a very pure form of carbon and it's very stable. And this we sell to soil enhancing and to soil inputs and sometimes to water treatment as well. And the third part, of course, is the carbon removal credits that we're trading today in the voluntary market, not in the regulated market, which is growing rapidly. So why is this? Why are our carbon credits interesting to clients? We mainly have corporate clients at the moment, no governments, but mainly corporate clients who are wishing to actually get to their net zero targets with very tangible ways. And so, first of all, you can of course weigh the carbon. That carbon you see on the screen is made from walnut shells in our pilot facility in California. So you can actually weigh it, you can measure it, you can send it to a laboratory and see how much exact fixed carbon is in the material. And so you can actually very easily calculate how much physical carbon you brought down. And this is why it's such a great way to verify it and audit it is quite simple. The long permanence our material has, again, through lab tests and verified literature, we have derived that our half-life is over 1,000 years, and partially it could be up to 1 million years, for example. But 1,000 years is a very long time. And why that's important is that if you're promising to take away your emissions that you've done today, you want to know how long those emissions are going to stay down. Because if you can only promise a half-life of, let's say, 10 years, technically after 10 years, you should go and remove those emissions again. So in this way, the people who want to get to net zero targets or countries should think about longer lasting offsets or carbon removal strategies, or then repeatedly come back to them. And the third thing, of course, is that instead of actually hindering the transition to a green grid and clean electricity and clean energy, we're actually helping this transition by being a source for renewable heat. So if we partner up next to a food processing unit, they might have been using propane before, and we can actually bring that biomass generated heat to them. Or in district heating, we may be able to delay an investment of a bioenergy plant by just bringing more capacity to them from our waste heat. So this is how we can help the transition instead of hindering it. And this is, again, another way that we can actually partner with other carbon removal units instead of just saying that we need to compete against everybody. There's a lot of work to do. what our crazy North Star goal is 1 gigaton of carbon dioxide removal. And I hope to see a lot of other companies with this kind of a target as well. And 1 gigaton is 1 billion tons of carbon dioxide. And now, like the first slide, you remember, we need to halve our emissions by 2030. And by 2050, we need to remove everything that we haven't been able to decarbonize. So McKinsey estimates that that might be up to 10 billion tons of carbon dioxide removal from the atmosphere annually. And now, you know, us and everybody here today could not do that. We're very far from that capacity. This year, the annual global carbon dioxide removal capacity is somewhere like 3 million tons, maybe. So it's a steep ramp up, like said, and we need these kinds of crazy ambitious targets, and we need to work together towards actually making them so we can keep this planet under 1.5 degrees Celsius. All right, so a couple of words about us as well. What is our technology? It's a novel technology to actually rapidly transform biomass into biocarbons. And we do this by taking the biomass like nutshells to a very high temperature, over 750 degrees Celsius for a split second. And then we starve that carbon of oxygen so it doesn't actually burn away. So if you think of your fireplace and you're burning logs, you want all the heat and you'll only get gases and the heat and the ashes. But we actually have quite the opposite process where we want to stabilize as much of the carbon as possible from the biomass. And this technology was researched for over 10 years in academic settings, where it was originally invented for stopping deforestation because carbonization technologies were so inadequately inefficient. And so now we've transformed this technology, scaled it up 8 times in volume, and tuned it towards carbon removal and biochar manufacturing. And why is this a great way to draw down carbon? Again, capturing parts per million from the atmosphere is extremely tedious. You can imagine if you go out now, what kind of a machine or what things do you need to build to actually be able to remove parts per million? So we outsource this to our plant allies who do it via photosynthesis every day for free by using solar power. So this is a clean way to capture the carbon without needing to plug in a lot of electricity or energy needs or chemicals or anything. Secondly, our conversion is exothermic, so we're actually donating heat. Again, we don't need that huge amount of energy into the actual conversion, but instead we use part of the energy that's stored in the biomass itself. And thirdly, it's a safe way to actually store the carbon. You can hold it in your hand, and we don't need gigantic infrastructure or any kind of new structures to actually store the carbon safely for a very long time. Now, what do we do with the carbons? So each ton of this material that we manufacture contains over 3.2 tons of CO2 in a stable form. And biocarbon has been mentioned as one of the most scalable ways that we can do carbon removal today at scale, because again, we're leveraging biology that's doing it already with us. And so there's no additional environmental hazards or anything like that. And you can again calculate and verify it very easily. So we're using our carbons today to build soil resilience. So sometimes people think that, oh, biochar is some miracle thing that you can put in your soil and your crops grow 40% more in the first year. No, that doesn't happen. Carbon is structure. Each gram of it has 400 square meters of surface area. And you can imagine what that does for all the soil microbial activity. It can also help sandy soils actually maintain some of the structure so that nutrients and water cannot leach away. And in clay soils, it can help with aeration and compaction. So really, it's all about the structure. It doesn't have nutrients. There's no fungi that's going to eat it. So really, it's about using it together with nutrients. And in a second, I'll get to why that's actually important. So we have some exciting research ongoing, and maybe next year I can tell you more about it. But some of you might know these 9 planetary boundaries. They're from the Stockholm Resilience Center. And we're not researching with them, but we're researching with Helsinki University and tens of other universities around the world at how can biocarbon actually help in these planetary boundaries. So these planetary boundaries, if you look at them, there's climate change, biosphere integrity, land systems change, biogeochemical flows. So for example, we're researching how can biochar actually retain nitrogen and phosphorus so that we don't have this nutrient crisis, what's going on around the world, where we're polluting all of our environment and our oceans with too many nutrients that are not being plant absorbed. So how do we actually counteract these? And of course, the aerial greenhouse gas emissions from that. And how do we help land system change in a way that biochar, first of all, doesn't put pressure on it, but secondly, that we could keep our soils fertile for longer in a way that we don't have to deforest for food production. So there's a lot of things, and of course, freshwater use is big in California and in other places around the world where the biochar can actually retain water in the soil for longer. So there are different ways that the biocarbon can actually play a role in the systemic planet and in the systemic sciences of our environment. It's not just the carbon removal, but actually further good. And this is what we hope to find out more about in the next years. It's I think it's utmost exciting part of this as well. And so who's building all of this? We have an amazing team, really great investors who just came on board. We have advisors with decades of experience in climate finance and in building different kinds of biotechnologies. And of course, as a necessary input for this kind of a intelligent audience, we're definitely hiring, and we're always looking for more people to join us on our mission of mitigating climate change. So thank you very much today. And it was excellent to be here with you today at MTech.
Henrietta, kiitos, I believe is what they say in Finland. Thank you very much. Just to be clear before you go, that gigaton target, which is 1 billion metric tons, is that just a carboculture goal, or is that with a number of companies? Is that the goal you have set yourself? To remove 1 billion metric tons?
We've set ourselves that goal. That's a great question. Yes, we've set ourselves that goal because we thought that if we aren't doing it for that kind of a North Star or this kind of a crazy goal, then why are we doing this at all? But there are other companies as well who have this target. And there are, in fact, some funds as well who don't invest in companies if they don't at least have a target of removing 0.5 gigaton out of the atmosphere annually. That's like, I think Breakthrough Ventures might still have it, and some other funds. But it's very, very difficult. And obviously no company in the world is able to do this today, not even the biggest giants. So we have a long way to go.
Well, look, kiitos, thank you very much for being with us. We hope we'd see you next year in Belfast, and by then you'll be closer to that target. So thank you very much, Henrietta Moon, founder, CEO of Carboculture in Finland via London. So thank you.